So let's wrap up the conceptual part of chapter 3 with the test level problem. All right. Now, on a test or a master set, I explicitly written out what each of these is. I don't want to spend a lot of time writing it down, but hopefully the verbal description will be enough. The object is going to start at A with an initial speed of 0. So it starts on rest. It's going to slide down, transition into this flat area, the level area, and then slide down another ramp. It's going to go across this flat area, up here, and then back down, transition up, and then at J it's going to stop. This symbol down here is telling us that the kinetic friction, that's the K for kinetic, technically that's the coefficient of kinetic friction is not 0. In other words, there's friction along here. If there were no friction along here, then that box would move get all the way back up to A again, but I wanted to stop sooner than that. Do I have the wrong spot? Do I need that here? It is accelerating there. There's a bomb that tips over. There. So H and D is the last moment before it's on the flat surface. G and E is the first moment after the flat surface. F, it's the turnaround point. C and I, it's the first moment the thing is on the curved surface here. J and D is with that last moment on this curved surface, or the last moment on that surface, or the moment just before it gets to the flat area. There's a box here. All right. Questions about what the problem is before we get into plus minus 0?
I can't see what that says.
That's a Greek letter mu
Okay.
with a subscript K.
Okay.
It's not 0. It's
Okay.
just shorthand for there's friction there.
Is there only friction on that bottom line?
Yes.
Is which way is the friction going?
It opposes the relative motion, so when the box is going that way, friction's
That's
acting
what I
this
would
way.
say. But
And
when the
box
box,
is going,
okay.
friction's going that way. Positive direction is this way. And let's make this the origin. It is, the box is at the origin at time D and H.
So then the box shouldn't be drawn at D and H, then at A?
But, sorry?
If the origin is at DH of the box, you drawn at D?
You don't have to start at the origin. And why not?
Oh,
If I had a coordinate system, you know, the classic math, X and Y axes, and I'm drawing lines on it, I don't have to start here, I can start over here, move around. Matter of fact, most of us were not born at 0 latitude, 0 longitude. We started someplace that wasn't 0, 0 on the world scale. All right, so position, displacement, velocity, acceleration. So I got A, B, B, C, 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 All right. On a test, I provide this for you, so you're not writing all that out. I'll give you the table which does it. So I recommend for a position, let's figure out where a position is equal to 0. At what time is the position equal to 0?
Did you say at A it starts at 0?
The box starts at A,
At 0, I thought you said the velocity.
but the speed is 0.
The speed is 0, okay.
What is position?
Comparison to the origin.
Yes.
So it's
Yeah, so it's 0 at D, and,
H.
yep.
H.
If I am before it gets to the origin, so from A to D, not including D, is that negative position, positive position, what is it?
negative.
Yeah. So it's negative all along here. What about from D to H?
Positive.
And then H to J?
Negative.
It can only go, if I'm switching from positive to negative, it has to go through 0. So, what about, how is displacement? Oh, questions on position? Displacement? How is displacement different than position?
It's from the starting point
Okay, so where's displacement equal to 0?
at A,
And then,
positive.
the entire time?
No, wait, yes, yeah.
Because it is to the right of A the entire time, other than at that moment of A. What about velocity? Where's the velocity equal to 0?
It's probably gonna go over at B.
Why B? You say it stops at time B?
No, oh,
It speeds up
Pardon?
when it speeds up, right? Velocity is when it speeds up.
The velocity is when it's moving.
it wouldn't be 0 because it's not stopping
Right. Okay, where is it stopped?
at A.
All right, so velocity is 0, A, that's how the problem starts, with it at rest. Because I said that, okay?
F.
Yeah, F.
Yep. F, that's when it's farthest to the right before it starts heading back. And?
J.
Yeah, it stops when it gets to J. So now we have in between here, so in between my zeros, it's either gonna be all positive or all negative. In other words, this is all positive or all negative. This is all positive or all negative. Not necessarily the same as that side. What determines the sign of whether something is positive or velocity is positive or negative?
The direction,
Of,
the arrow, where you designated where this that is positive to the right.
yeah, so when is velocity positive?
From A to F.
So, in other words, when it's moving to the right.
Correct.
Yeah. So velocity doesn't care about where you are, just cares about which way you're moving, so it's positive. As long as it's moving to the right, it's positive. What about from F to J?
It would be negative.
Negative, cause it's moving to the left.
Yeah. I know that when it is speeding up, acceleration and velocity are the same sign. So let's at least get that part down. So between A and B, is it speeding up? Slowing down?
Speeding up.
Speeding up.
I hope so, because if it starts at rest and if it didn't speed up during that region, that means that anything past A doesn't exist. So from A to B, it is speeding up, so they are the same sign. What about from B to C?
0.
It's maintaining its velocity. What about from C to D?
Speeding up.
D to E?
0. Oh,
There's friction involved.
right. That's what I was remembering.
Is friction gonna make it move faster or slower?
Slower.
Slower.
Not always the case, but yes, in this case, it's definitely. So it's slowing down from D to E. Or from a force diagram point of view. So in this region right here, when it's moving to the right, I have weight acting down, I have normal force acting up, and then friction opposes the motion, I have friction acting to the left. The net force, these will balance each other out. The net force is to the left, which is negative. All right, so it slows down in that region. So that it's speeding up, this it's maintaining its velocity. If you look at it just right, you get that nice three-dimensional effect. E to F?
It's negative.
Speeding up.
It speeds up as it goes up the ramp. Saying it slows down as it goes up the ramp.
I'm not sure what I'm saying.
Negative.
As I'm going up the ramp, I know it stops at F, so it's got to slow down. It's moving as it goes up the ramp, it's got to slow down going from time E to time F. So this is slowing down. From F to G, what's it doing?
Speeding up.
So it's the same sign, so it's still negative, it's speeding up. And then from E to D,
G to H.
G to H, thank you. Going backwards this time, I think. All right, going from G to H, what's it doing? It's got that friction
It's
factor in
friction,
it.
so it's negative.
Pardon?
Negative,
Why?
because there's friction.
Which means, what is it doing physically?
Slowing down.
And my velocity is negative, so my acceleration is positive.
That's right.
Because as it's going that way, my force diagram, I still have normal force acting up, my weight acting down, but my friction is acting this way to the right, which is the positive direction. From H to I, speeding up or slowing down?
J slowing down because it's going up?
So
Yeah.
positive.
Correct.
I to J,
I to J is 0, it's flat.
and then it stops at J. It's going from I to J, it would be just crawling along, because at J it stops. So it's going from some negative velocity to 0, which is a positive J. So that'd be plus. Now, I have left some gaps here. We need to fill those in. Usually at the transition, it's gonna be, it's the same sign on both sides, there's a good chance that it is the same sign. So at E, it's slowing down, it slows down actually from D all the way to F. It's slowing down that entire time. It's moving to the right. It's gonna be the opposite sign. At G, well, G and E, it's in the same position. I guess G, it's still going down the ramp. It's speeding up just a little bit more as it gets onto the regular level. So G would also be negative. And then at D, it is speeding up at time D. And D is negative. Yeah, and this is an example of a mistake, because I would contend that's positive, so there is a 0 point somewhere in here that I left off. So this is what I get when I make it up on the spot. Yeah, I was afraid it's like that one. Let's see, did I do it again somewhere else? So at C, it is on that ramp, it is speeding up. B, it is still on the ramp, still slightly speeding up. A, it is moving it's gonna be moving to the right, speeding up. And I guess we're left with it, on the other side, H,
It's going up, right, or stop?
so it's starting to slow down there. And also, I've got 2 pluses there, odds are in the middle is plus. And then at I, it's still on the ramp, still slowing down. So one small mistake there. The test problem should be better thought out.
Is this gonna be on Thursday's quiz?
Wait, Thursday's test quiz,
That's on.
no, Thursday's quiz is on chapter 2.
Okay,
This is chapter 3 stuff.
this is chapter 3.
Yeah. But this is a test level problem,
Okay.
but I know what you're thinking. We've done plus minus 0, a whole bunch of that, and we've done a bunch of vector stuff, but what I feel like you're thinking right now is, where's the math? I haven't really had to use a calculator enough. So when we come back on Thursday, it is, yes it is, after the quiz, we'll get into some math. Yes!
Yay.
Yay.
Where's the Ricardo Montalban? Smiles, everyone. Don't understand the reference, ask your parents. Actually, you know what you want reference. Wherever you put it down is where I want it. There we go, the stack has been created.
I remember has